All right, so the midterm is 50 questions, all multiple choice. Make sure you know how to do the questions from the review, but there are also some questions that aren't on the review that I want to go over with you guys. So some formulas that you need to know. You need to know the vertex formula, so how to find the vertex. It's negative b over 2a. That'll get you to find your h in your vertex. To find the k, you plug it in. And then our vertex form of the equation is y equals a times x minus h squared plus k. So if we find our vertex, or even if the vertex was given to us, you'd plug it into your equation. Remember, you always change the sign of what's on the inside of the parentheses. In the case, you can see it. You also need to know the midpoint formula. So it's the average of the x's and the average of the y's. So x1 plus x2 over 2, comma, y1 plus y2 over 2. You need to know your distance formula. So distance formula is the square root of x2 minus x1 squared, bless you, plus y2 minus y1 squared. You got to know your circle formula. So y equals x minus h squared, actually it's not y equals, I lied. X minus h squared plus y minus k squared equals r squared. So the center would be h comma k. And your radius is r. You should know your quadratic formula too. Negative b plus or minus the square root of b squared minus 4ac over 2a. So these are formulas that you should know that are not given to you. You'll have some that are given. So everything that was given on test 3, I'll give you guys for the review. So the unit circle, the identities, and the sum and difference formulas. I don't think so. Also, I'm going to give you guys the interest formula. So A is equal to P times 1 plus R over N to the power of N times T. This is given, but you guys just need to know what to do with it. And also your A PERT formula. So A is equal to P times E to the power of RT. So you would use the first one if N was compounded a certain amount of times. So if N's compounded quarterly, your N would be 4. If it's compounded monthly, your N would be 12. And then you use your PERT formula when it's compounded continuously. Some other things that you need to know for the midterm. So there's not really any questions on the review, but you do need to know how to factor. So factor normally, factor when A is not 1, factor when you have 4 terms. How would you factor when you have 4 terms? Grouping, so make sure you know how to group. I don't think that there's any questions on the review of solving triangles, but you need to know SOHCAHTOA. So if it gives you your opposite and adjacent, you could find tangent, or you could find your hypotenuse using Pythagorean theorem, things like that. So how to solve a triangle. you'll have some trig questions. So just like the last test where you'll have to solve, verify, and find the exact value. Bless you. So just like the last test. You'll have an increasing, decreasing, and constant question. So don't think that it's on the review, but look back at old tests and quizzes or old reviews. Increasing, decreasing, constant. It might give you a graph and say, on what interval is it increasing? And what interval is it decreasing? Something like that. And then also make sure you know how to find the end behavior. So end behavior, we look at the degree. So our leading term, if the degree is even and it's positive, the end behavior goes in the same direction and it would go up if it's positive. If it's even but negative, they both go down. If it's an odd degree, so an odd exponent, and it's positive, your overall slope of the graph would be increasing, so it starts going down and ends going up. If it's negative, the overall slope of the graph would be decreasing, so it starts going up and ends going down. All right, so you need to know everything on the midterm review plus this stuff. So there aren't really questions about these or these. So make sure you look back at old tests, quizzes, homeworks to help you. You can practice these from old test quizzes, homeworks would be helpful. Everything starting else with number one on the review. So evaluate the indicated function for our composition function here. We're subtracting f minus g. If this said f minus g of x, we just subtract the two functions together. So we take f first, so x squared plus 2 minus g. Now when we subtract g, we got to be careful because we have to put it in parentheses. So when you're subtracting, make sure you put what you're subtracting in parentheses. Distribute the minus, so x squared plus 2 minus x plus 3. Combine our like terms, so x squared minus x plus 5. This would be f minus g of x. But let's find f minus g of 4t. So that just means we plug in 4t into the x's. So f minus g of 4t. Whatever's in the parentheses, we plug in to the x's. So this would be 4t squared minus 4t plus 5. One last step just to simplify a little bit. 4t squared would be 16t squared minus 4t plus 5. That would be our answer. Any questions here? You won't have any domain questions for composite functions, so I'm going to skip number 2. Let's look at number 3. So when we find the inverse, we want to switch the x and y and then solve for y. So f of x becomes x and x becomes y. So we want to undo everything on the right side of our equation to get y all by itself. What should we do first? Subtract 6. We have x minus 6 equals the square root of 2y. Then what should we do? Square both sides, so it'll cancel out with the square root. You don't have to FOIL. Remember, it's multiple choice, so look at your answer choices to help you. It'll probably leave it just as squared. So don't FOIL it out, just leave it. Equals 2y, and what's the last step? Divide by 2. So x minus 6 squared over 2 would be our answer. This is our inverse. All right, with number 4. Here we want to determine if the function's even, odd, or neither. We can plug in a number and its opposite. The number has to be greater than 1, so 2 and negative 2 would be a good choice. And if we get the same answer, they're even. If we get opposite answers, so the same number but different signs, it would be odd. And then if we get totally different answers, it's neither. So let's plug in 2 and negative 2. We plug in 2. We have the cubed root of 2 minus 6. So that'd be the cubed root of negative 4. We plug in negative 2. We have the cubed root of negative 2 minus 6. So the cubed root of negative 8. Are these the same answer? Are they opposite answers? No, they're completely different. So what would our answer be here? Neither. Five says find the inverse. We already did one of those, so I'm going to skip it. All right, so on the extra formulas that you needed to know, you might have a circle question. So it could either give you the equation. So let's say we had x minus 2 squared plus y plus 4 squared equals 16. And it could ask you what's the center. What would our center of the circle be here? Would be 2 comma negative 4. You always switch the sign of your h and k. What would our radius be? Take the square root of what it's equal to, so our radius would be 4. It could give you the center and the radius and ask you for the equation of the circle. So it could give it to you backwards too. This is just a circle question. So if it gave you the center is 1 comma 0 and the radius is 2 and it asks for the equation of a circle, we'd have x minus 1 squared plus, we wouldn't say y minus 0 squared. How would we write that? Just y squared equals r squared. So 2 squared would be 4. So circle questions, you just really need to know the formula to be able to plug it in or identify your center. There's really not much math. You just got to know the formula. Let's look at number 6. So you will have domain questions, just not domain of composition functions, but we're going to do the domain for A and B. So we have 3 rules that we have to follow with domain. If you have x under the square root, your denominator, or if you have x in a fraction and your denominator of a fraction, whatever's in your denominator can't be equal to 0. If you have x under a square root, you set whatever's under the square root greater than or equal to 0. And then if you have a square root in your denominator, then it would just be greater than 0 because it can't be equal to when it's in the denominator. All right, so for A, since x is in our denominator, we would set it not equal to 0 to find the domain. Subtract 1 on both sides, so we just solve normally. X squared cannot equal negative 1. If we take the square root of both sides, what do we get? What's the square root of negative 1? I. Well, plus or minus I. But we can't have imaginary in our domain. There's no real number that we can't plug into x here that would make this 0 in our denominator. So here, this would be all real solutions. Or we would say negative infinity to positive infinity. These mean the same thing. It's multiple choice, so whatever the answer choice says, it'll say either one of these. So this would be all real solutions because you end up with an imaginary. For B, since we have a square root, whatever's under the square root, we would set greater than or equal to 0 because we can't have a negative under our square root. So x squared minus 16 is greater than or equal to 0. Add 16 to move it to the other side. Square root both sides. So x is greater than or equal to what? Plus or minus 4. Perfect. Square root of 16 would be 4. So we technically have 2 answers here. Just to see it visually, we've got negative 4 and positive 4. X could either be talking about the values in between these 2 numbers or outside of these 2 numbers. We can plug in a number to test. So 0 is a nice number in between. If I plugged in 0 here, the square root of 0 minus 16. Can I take the square root of negative 16? No, because it would be imaginary. So 0 does not work. So we're talking about the numbers outside. So when we write our interval, it would be negative infinity to negative 4 with a bracket because it's greater than or equal to. And then 4 to infinity. Seven says determine whether the lines passing through the points are parallel, perpendicular, or neither. So we have to find the slope. So if you're making a list of formulas that you need to remember, slope is one of them. So our slope formula is y2 minus y1 over x2 minus x1. So my points are x1, y1, x2, y2. So we plug everything in, we get 0 minus negative 4 over 7 minus 2. That would be 4 over 5. So 4 over 5 is our slope for line 1. Let's find our slope for line 2. x1, y1, x2, y2. Y2 minus y1 would be 0 minus negative 8 over x2 minus x1, 4 minus 14. So we get 8 over negative 10, which would simplify to negative 4 over 5. Are these points parallel, perpendicular, or neither? Are these lines parallel, perpendicular, or neither? It would be neither. In order to be parallel, they have to have the same slope. If they're perpendicular, they're going to have opposite slope or opposite reciprocal slopes. So it'll be the flip of the number and the signs are going to be opposite. And then if they're not the same and they're not opposite reciprocals, it would be neither. So this one almost tries to trick you because they're opposites, just not opposite reciprocals. So it would be neither. Let's just say for practice, so looking at line 1, that it wants us to write the equation of this line. So for question number 7, there's 2 different lines here, but we're just going to write the equation for line 1. How would I write the equation of a line? We can do point slope because we have a point and the slope. So I'm going to do this point here. You could pick either point. You'll end up with the same answer. But our point slope form is y, bless you, minus y1, bless you, is equal to m times x minus x1. So y minus our y1 is 0 equals m is 4 over 5 times x minus 7. Now look at your answer choices. It might be written in slope-intercept form. It might be written in point-slope form. If it was written in point-slope form, our answer would be y equals 4 over 5x minus 7. Oops, I forgot the parentheses. This would be point-slope form. If it asked for slope-intercept form, what would we have to do? Remember, slope-intercept form is y equals mx plus b. We got to distribute the 4 over 5. Now use your answer choices to help you. There might only be one answer choice that has the correct slope. So you wouldn't even have to put it in the equation of a line. If you find the slope, look at your answer choices and you use process of elimination. You might only have one answer choice that has the right slope. You might have 2, and then you have to do some more math to figure it out. So when we distribute, we get y equals 4 over 5x. This would be minus 28 over 5. So this would be slope-intercept form. Number 8 says determine the x-intercepts. X-intercepts, zeros, solve. These all mean the same thing. We're going to change our f of x to be 0 and just solve for x. What would we do to solve for x here?
You can like divide it by 2.
Awesome. We want to factor, but before we factor, we can take out our GCF. So we're going to divide everything by 2. So we get 0 equals x squared minus 2x minus 8. What are 2 factors of negative 8 to add to negative 2? Negative 4 and 2. So x minus 4 and x plus 2. So x equals 4 and x equals negative 2. Now again, it's multiple choice, so your answers might be written like x equals, depending on how the question's asked. They might be written as points. So for our x-intercepts, it'd be 4, 0, and negative 2, 0. You wouldn't have like x equals 4, negative 2, and 4, 0, negative 2, 0, both as answer choices, because they're both right. They're just written different ways. Just find your x-intercepts. Same thing as finding the zeros, same thing as solving. Similar to factoring. Factoring, you would probably just stop here. But look at your answer choices to help. How would we factor if we had 4 terms in this question? By grouping. So make sure you know how to group 2. In number 9, we want to find the zeros and state the multiplicity. Here, we have 4 terms, so you could factor by grouping. If grouping doesn't work, what could we do? What could we do if grouping doesn't work? So if grouping doesn't work, you can do last over first. That gives you your possible options, and you do synthetic division. When you get 0 as your remainder, that would be one of your solutions. Here, grouping works, so we're going to practice grouping. But don't forget, if grouping doesn't work, last over first is an option to find your zeros. So we're going to group the first 2, group the second 2. What's our GCF from the first group? X squared. We're left with x minus 5. What's our GCF from the second group? Negative 4. And we're left with x minus 5. So in order for grouping to work, your inside parentheses have to be exactly the same. So they're exactly the same here. We're going to take that out as an x minus 5. And we're left with x squared minus 4. If you want to factor this a little bit more, you can, or just set them both equal to 0 now. So x equals 5. X squared would equal 4. Take the square root. What else does x equal? Plus or minus 2. So we've got 3 answers here. X equals 5, negative 2, positive 2. Do we have any multiplicity? No, we don't have any answers that repeat. Multiplicity is the repeating of answers. We don't have any answers that repeat, so this would have no multiplicity. Or multiplicity of 1, because there's just 1 of each solution. It's multiple choice, so just look at your answer choices and see what your options are. It'll either say multiplicity of 1 or no multiplicity, because nothing repeats. All right, number 10, we want to find the slope and y-intercept of the equation of the lines and sketch the line. So to find our slope, we want it to be in y equals mx plus b, because then we can clearly identify what our slope is and what our y-intercept is. So let's rearrange this equation. I'm going to add 8x, move it to the other side, and subtract 16. So negative 4y equals 8x minus 16. Divide by negative 4. So y equals negative 2x plus 4. What's our slope? Negative 2. What's our y-intercept? Perfect. 0, 4. Now you might have a question like this where it asks you to graph. Again, it's multiple choice, so look at your graphs to help you. Your y-intercept is where you cross the y-axis. So we would cross the y-axis at 4. So we can put a point there. When we have the slope of negative 2, we go down 2 and to the right. So down 2 to the right 1, down 2 to the right 1. Our line would look like this. So look at your graphs to pick which one has a y-intercept of 4, which one has a negative slope, which line is decreasing. Use your graphs to help you. 11 and 12 are super similar. We're going to do 12. We could do either one, but let's just do 12. So to find the vertex, we're going to use the formula negative b over 2a. And then we plug it in to find the y. So this is our a, b, and c. So negative 4 over 2 times negative 1 be negative 4 over negative 2, which simplifies to what? 2. Plug it in to find the y, or your k. So negative 2 squared plus 4 times 2 plus 11. Common mistake that people will make is that they'll keep the negative attached to the 2 and square it with the negative. But that negative's on the outside. So square the 2 first and then multiply it by the negative. We get negative 4 plus 8 plus 11. So 4 plus 11 would be 15. So our k is 15. Now for practice, let's put this in vertex form. We'll write y equals, so we'll write it as an equation. Our vertex form is y equals a times x minus h squared plus k. So our vertex is our h comma k, and our a comes from the equation. So y equals negative 1 times x minus 2 squared plus 15. And then just for even more practice, let's graph this. So again, your graphs are multiple choice. So just knowing your vertex will probably give you enough process of elimination to pick the right answer. But our vertex, we go to the right 2 and up 15. So our vertex would be there. Does our graph open up or open down? How do we know that it opens down? A is negative. If your leading coefficient's negative, it's going to open down. So our graph would look like this. So for 14, we want to find the vertical and horizontal asymptotes. So vertical asymptotes, we set the denominator equal to 0. So set the denominator equal to 0. We'd subtract 2 on both sides. 5x equals negative 2, divide by 5. So x equals negative 2 over 5. So this would be our vertical asymptote. Horizontal asymptote, we have to look at the degrees. So we look at the degree of our highest term on top, the highest degree on top, and the highest degree on the bottom. If they're the same, then what do we look at? The coefficients. So our horizontal asymptote here would be y equals 3 over 5. So if they're the same degree, you look at the coefficients. So the rules for horizontal asymptotes: if the numerator is higher than the denominator, a higher degree than the denominator, our horizontal asymptote would be none. We don't have one. If they're the same, so let's say I had 4x squared over 3x squared, then we look at the coefficients. So this would be y equals 4 over 3. And then if our denominator is higher, if I had x over x squared, then our horizontal asymptote would be y equals 0. So these are our 3 rules for horizontal asymptotes. If the degree on top is 1 degree more than the degree on the bottom, that means that we could possibly have a slant asymptote. How would we find a slant asymptote? Anybody remember? How can we find a slant asymptote? We divide. So you could either do long division or synthetic division. You divide, remember that you drop the remainder. Your slant asymptote's going to be a line, so it'll be in the form of y equals mx plus b when you divide. So that's if your numerator is 1 degree more than the denominator. You divide to find your slant asymptote. We'll practice some division questions as we go through the review. But keep that in mind to find a slant asymptote. All right, let's do 15b. So remember that when you're adding or subtracting with i's, you can only combine real numbers with real numbers, imaginary numbers with imaginary numbers. So here, before I start adding things together, I want to distribute the -3. So this would be -24 minus 6i. So let's add all of our real parts together. 4 plus 2 minus 24 would be -18. And then we can combine all of our imaginary parts together. 3i minus 4i minus 6i. 3i minus 4i would be -1i, minus 6i would be -7i. So that would be our answer. In standard form, the real part comes first, imaginary part comes second, but again, it's multiple choice, so just pick the right answer. Yeah. So B would have no horizontal asymptote, going back to number 14. No horizontal asymptote because the degree on top is bigger than the degree in the denominator. But because the degree in the numerator is 1 degree more than the denominator, it will have a slant asymptote, so we divide to find the slant asymptote. So when we divide, I'll practice long division. We have x squared here, x plus 2 on the outside. Because it's just x squared on top, I'm going to put in a 0x plus 0 just to act as placeholders to give me all of my terms. Again, you could use synthetic division if you wanted here. I'll practice both ways to show you. X squared divided by x would be x. Then we multiply x times everything out front, so we get x squared plus 2x. Change the signs and combine. The x squareds cancel. This would be -2x. Divide again, so -2x divided by x would be -2. Everything after this is just the remainder, which we drop the remainder. So our slant asymptote would be y equals x minus 2. If we were to do synthetic division here, we put the numerator inside the box, but it's just the coefficient, so it would be 1, 0, 0, because you need the zeros as placeholders here. Outside the box, you change the sign. So if we had x plus 2 and set it equal to 0, we would get x equals -2. So -2 goes on the outside. Drop down the 1, multiply, we get -2, add -2, multiply 4, add 4. So this would be x minus 2 with a remainder of 4, but we drop the remainder anyways. So you could do it either way. Long division, synthetic division, you just divide to find the slant asymptote. Forgot to hit record with that one, so that won't make it in the video, but here's the work. Are we good with this one? Okay. We're going to skip 18. We'll practice the synthetic division one a little bit later. Let's look at 19. So to show that x is a solution of the third degree polynomial, we want to use synthetic division. It tells us here x equals, so we're going to put exactly what it says on the outside. So 3 is going to go on the outside. We put our coefficients inside the box, so 1, -1, -9, -9. Drop down the 1, multiply, add, we get 2, multiply 6, -3. It doesn't work, -18, because remember we need 0 as the remainder. So x equals 3 is not a solution. So let's pretend that this has a plus sign here. Now let's see if 3 is a solution. So we're going to put 3 on the outside, 1, negative 9, and 9 inside. Drop down the 1, multiply, add, multiply, negative 3, negative 9, 0. So now x equals 3 works. To find our remaining solutions, we're going to factor this. So it'd be x squared plus 2x minus 3. What are two factors of negative 3 that add to 2? 3 and negative 1. So x plus 3, x minus 1. So x equals negative 3 and positive 1. So in order for it to be a factor, you need 0 as your remainder when you do division. This one, there was just a typo in the question. Let's do 20. Given x minus 4 and x minus 3, find the remaining roots, right, in fully factored form. So it gives us 2 of the answers. Let's use synthetic division to find the rest. If x minus 4 is one of our factors, what would x equal? 4. So we're going to put 4 on the outside. We have 1, negative 5, negative 2, and 24 on the inside. Drop down the 1, multiply 4, add negative 1, multiply negative 4, negative 6, negative 24. Does it work? Yes. From here, if you wanted to, you could just factor it and find your remaining zeros, but it also tells us that x minus 3 is a 0, or root. 0 and roots are the same thing. So what else does x equal? If 3, perfect. If x minus 3 is a factor, then x would equal 3. So we can do synthetic division again. Put 3 on the outside. So this would be 1, 3, positive 2, positive 6, 0. So 3 works. So from here, if we start with x to the 3rd power, the first time we did synthetic division, this would be x to the 2nd power. The next time we did synthetic division, it would just be x. So we have x plus 2. X plus 2 equals 0. X would equal negative 2. So that would be our remaining 0. To write it in fully factored form, just write the factors out. So x minus 4, x minus 3, and x plus 2. Now, it might be written either way, so just look at your answer choices. X equals 4, 3, and negative 2. So when you put it in factored form, you always change the sign. All right, 21, describe the transformations. You guys need to know your transformations. Multiplying by a negative on the outside is going to be a reflection on the x-axis. Multiplying by a number greater than 1 on the outside is a vertical stretch. What about adding 4 on the inside? Which way does that move our graph? Adding 4 on the inside is left, perfect. So left 4. And then subtracting 1 on the outside, down 1. Now you may be asked to graph using your transformation, so apply the transformations by graphing. If I had something like, actually we'll graph this just for fun. So this comes from our parent function, which is an x squared graph. So the basic graph of this would be a parabola shape. If we move our parabola to the left 4, our vertex is moving to the left 4 and down 1, but it's also flipping on the x-axis. So our vertex here, because this is pretty much written in vertex form, our vertex of this parabola would be -4, comma -1. So we're going to move it to the left 4 and down 1. But it also flips upside down because it has a reflection on the x-axis. It has that negative, so it would go upside down here. So this would be our graph. So you might be asked about transformations, but applying it to the graph. So make sure for sure you know which way you're moving, left or right, up or down specifically. All right, looking at 22, it says write the equation in its equivalent form. We'll do A and C since we have an exponential and log. So if it gives us an exponential equation, when we rewrite it into log form, we start with the base. So our base would be 4. So log base 4. The other two numbers switch positions. So 64 equals 3. If the 4 and the 3 are attached here, they're not going to be attached when it's in log form. Log base 4 of 64 equals 3. For C, let's do a log 1. So we're going to start with the base. So 4. The other two numbers switch positions. If 4 and 64 are attached here, they're not going to be attached in exponential form. So 4 to the power of 3 equals 64. So with B, we're going to start with our base. So log base 5. The other two numbers switch positions. So 1 over 125 equals -3. D is actually missing a number here. If you want to put it as x, we'll put this into exponential form too. So 5 to the power of 3 equals x. We're going to skip 23. You won't have a graphing exponential, so we will skip it. Let's do 24. Determine the zeros. When you have a fraction, if your numerator's 0, it makes the whole fraction 0. So if we were determining the zeros here, you just need to set the numerator equal to 0 and solve. So if 2x squared equals 0, what does x equal? 0. Divide by 2, take the square root, x equals 0. So if you don't remember that shortcut, if we had 0 equals 2x squared over x squared minus 25, you could multiply both sides by x squared minus 25 to get it out of the denominator. X squared minus 25 will cancel out on the right side. X squared minus 25 times 0 is still 0. So 0 equals 2x squared. So same idea, just an extra step. If you don't remember that, if you have a fraction, all you have to do is set the numerator equal to 0 to find your zeros. Good with this one? 25. We want to write the quotient in standard form. So here we're dividing with i's. When we are dividing with i's, our goal is to get the I out of the denominator. So I want to multiply by the conjugate of our denominator. So we have 3i plus 3. I'm going to multiply it by 3i minus 3. If you want to rearrange this and put it in standard form, you can. You'll end up with the same answer, but you don't have to. Just change the sign in the middle. Just the sign in the middle changes. Whatever we multiply to the bottom, we also have to multiply to the top. So up top, we can FOIL it out. 5 times 3i would be 15i. 5 times -3 is -15. -4i times 3i would be -12i squared. And -4i times -3 would be +12i. What do we do when we have an I squared? It changes to be -1, so -12 times -1 would make it +12. So then we can combine our like terms. Negative 15 plus 12 would be negative 3. And 15i plus 12i would be plus 27i. So that would be your numerator. Let's do the same thing for the denominator. You could either FOIL it out or use your conjugate shortcut. Our conjugate shortcut is a squared minus b squared. So if you're multiplying conjugates together, you can use your shortcut. So that would be 3i squared minus 3 squared. 3i squared would be 9i squared minus 9. What does I squared change to? Negative 1, so that would make this a negative 9. Negative 9 minus 9 is negative 18. Now, it might have this as the answer choice, but we can simplify it a little bit more. It'll probably have the simplified version as your answer choice, so divide everything by negative, or just 3. Divide everything by 3, or negative 3. So we get negative 1 plus 9i over negative 6. It might divide everything by negative 3 just to make the denominator positive. So that would be 1 minus 9i over 6. Same thing. Just look at your answer choices to see which one matches. I was going to skip 26, but just for practice. 7 minus 5i squared is like saying 7 minus 5i times 7 minus 5i, and then just FOIL these together. I know you guys know how to FOIL, but just don't forget, when it's squared, you absolutely cannot distribute the squared. Write it twice and FOIL it out. 27, when we're solving, and it's an exponential function, your x is in the exponent, you want to use logs to help you solve. So I'm going to take the log of both sides here, log base 5, because whatever your base is of the exponent has to be the same base of the log. So bless you. Log base 5 of both sides. Because log base 5 of 5 will cancel. So we're left with 3x equals log base 5 of 6. So whatever is your base that has the exponent, that's going to be the base of your log. If your x is in your exponent, you use logs to help you solve. If your x is in a log, you use exponents to help you solve. So pretty much we just rewrote this into log form. You can think about it either way. We just rewrote this in log form. Now to solve, we can put this in the calculator. So 3x equals, to put log base 5 of 6 in the calculator, you need your change of base formula. So log of 6 over log of 5. Remember that the base goes on the bottom when you're using the change of base. You should get 1.11328. Then our very last step is divide by 3. So x equals 0.371. It'll probably round to 3 decimal places, but again, it's multiple choice. Good here? Let's do 28. So we want to find the x-intercept. X-intercept, we make y 0. So I made y 0 here. To solve, how could we get rid of the ln? What will cancel out with an ln? E, we make the big base e on both sides. So e to the power of ln will cancel. We're left with x minus 7 equals e to the power of 0. What is e to the power of 0? No. 1. Put it in your calculator if you don't know. But hopefully you know. Anything to the power of 0 is just 1. So last step, add 7 to both sides. X equals 8. B is super similar. If we're finding the x-intercept, we make y 0. Make the big base 2 on both sides, so it'll cancel out here. So x minus 2 is equal to 2 to the power of 0. What's 2 to the power of 0? 1. Add 2 on both sides, x equals 3. For solving questions, you could always just take your answer choices and plug them into the equation if you don't know how to solve it all. If you're completely lost, take your answer, plug it into the equation. You'd have to check every answer choice, so it might take some more time, but if you are checking your work and have a few questions you want to do that for, if you have time, it's one way to help you out. So use your answer choices. Let's do 29. If we have a log equals a log, they can cancel. So then we're just left with 5x minus 7 is equal to 2x plus 5. Combine like terms. So 3x equals 12. Divide by 3. X equals 4. We're going to skip 30. Let's do 31. If you have the same base with the number here, they cancel. You're left with whatever your exponent is. Here, if there's no exponent written, it's implied that it's a 1. So log base 9 of 9 would be 1. If you're not sure, put this in the calculator. Your change of base formula would be log base 9 over log of 9 over log of 9. It would be 1. 32, convert to radians. When we convert to radians, we multiply by pi over 180. You have your calculator. The answers will probably be written in simplified fractions, but put in your calculator, convert to fraction, whatever you need to do. You could simplify. I think 45 goes into both of these. Yeah, it goes into 225 negative 5 times, and it goes into 180 4 times. So this would be negative 5 pi over 4. Make sure you know how to convert to radians and from radians to degrees. Oh, let's convert from radians to degrees here. So we're going to multiply by 180 over pi. 6 goes into 180 30 times. So 30 times 11 would be 330 degrees because the pi's canceled. Find one positive and one negative coterminal angle. Coterminal angle is when you have degrees. You can add or subtract 360 as many times as you need to. You can add it more than once. You could subtract it more than once. If you have radians, you add or subtract 2 pi. So just put these in the calculator. Add or subtract 360 when you have degrees, 2 pi if you have radians. We'll do the radian one. So to find our coterminal angle, we are going to add 2 pi. We need a common denominator, so I can make this 14 pi over 7. So 25 pi over 7 would be a positive coterminal angle. To find a negative one, subtract 14 pi over 7, because that's 2 pi. So that would give us negative 3 pi over 7. Find the complement and supplement of the given angle. Complement is going to add up to 90 or pi over 2. Add to 90 or pi over 2. Supplement is going to add to 180 or pi. Complement and supplement have to be positive. So 2 positive angles that add up to 90 or 180. So for A, we don't have a positive angle that will add to 104 to make it 90. So there's no complement. To find the supplement, we do 180 minus 104. Just put it in the calculator. So we'd get 76 degrees. For 3 pi over 4 to find our complement, we would do pi over 2 minus the angle. We need a common denominator, so I would make this 2 pi over 4. 2 pi minus 3 pi would be negative pi over 4. Can we have a negative complement? Nope, so we have no complement. To find our supplementary angle, we do pi minus 3 pi over 4. So we can make this 4 pi over 4. That would give us pi over 4. So this would be our supplementary angle. (36) Arc length. Our arc length formula is S is equal to R times theta. When you're using the formula, your theta has to be in radians. So we want to convert it before we plug it into the formula. So we're going to multiply by pi over 180. We just said that this is going to be 5 pi over 4 because 45 goes into 225 5 times. So 5 pi over 4 is our theta, and our radius is 6. So S is equal to 6 times 5 pi over 4. Simplify. 2 goes into both 6 and 4. So this would be 15 pi over 2. Or you could multiply it together and then simplify at the end. For 37, it gives us S and R. So S is equal to R times theta. It's asking us to find theta. So we would do 8 is equal to 6 times theta. Divide by 6. Theta is equal to 8 over 6, which would simplify to 4 over 3. Since we're using the formula, this answer is in radians. 38 is good practice for solving triangle questions, but it gives us a point, so we'll graph it and then make our triangle. So we're going to go to the left to -9 and then up 12. So our point would be over here. So this would be our triangle. Our x values -9, our y values 12. How do we find our radius or the hypotenuse? Pythagorean theorem. So 12 squared plus -9 squared equals r squared. 144 plus 81 equals r squared. So this would be 15. Well, 225 equals r squared. Take the square root, so r equals 15. Is it going to be positive 15 or negative 15? Positive, because r is always positive. So this is our x, our y, and r is 15. So you can either think about it, if this is our theta, theta always comes from the center, so our theta would be here. You can think about it in terms of SOHCAHTOA. Or you could think about it in terms of x, y, and r. If it gives you just the triangle and you find all three things on the triangle, think about it in terms of SOHCAHTOA. But here, since it gives it to us as x and y, we can think about it in terms of x, y, and r. Cosine is x over r. So our cosine theta would be -9 over 15. Always simplify your fraction. We have -3 over 5. cosecant of theta. Cosecant's the reciprocal of sine. So this would be y over r over y, because it's the reciprocal. So cosecant theta would be 15 over 12, which would simplify to 5 over 4. All right, for 39, it's an exponential question, so we're going to use logs to help us solve, most likely. But we need to get the base all by itself first. So I want to divide both sides by 4. So 8 to the power of x minus 1 equals 8. Now the one time that we don't need to use logs to solve is if our bases are the same, or if you can get your bases to be the same. You could still use logs if you want to, but it'll just be easier if your bases are the same. Our bases will cancel, and we set the exponents equal to each other. What's the exponent of the 8 on the right side of our equation? 1. If there is no exponent written, it's implied that it's a 1. So we have x minus 1 equals 1. Add 1s both sides, x equals 2. This would be one of those questions if you are completely stuck at the beginning and you don't know how to solve, take your answer choices and plug it in. It's going to take more time to do that, but at least it'll be a way to find the answer. If you want to go through the test, everything's going to be worth 2 points. So go through the test, do the easy ones first, or whatever you consider easy, save the hard ones for last. Last question from the review, let's look at 40. We want to expand. So anything that's being multiplied, we expand it with addition. Anything that's being divided, we expand it with subtraction. So we have log base 7 of 40. 40 and x to the third power being multiplied, so we'd say plus, and every time we break it apart, each one gets its own log. Log base 7 of x to the third power. What do I do with the exponent? Bring it to the front, so this would actually be 3 log base 7 of x. And then minus, because we're dividing the z, so minus log base 7 of z to the 5th power. What do we do with the exponent? Bring it to the front. So 5 log base 7 of z. So this would be our answer. So when we condense, we're going to take any coefficients, we move those up top. And since we're adding, we're going to condense it with multiplication. So when we condense it down to a single log, so log base 8 of x plus 3 to the 5th power times x minus 6 to the 1/3 power. Now, it might be written as the 1/3 power. It also could be written as the cubed root. So you could see it as log base 8 of x plus 3 to the 5th power, and then the cubed root of x minus 6. Again, it's multiple choice. Just see which one matches the right answer. All right, so looking at the last test review, you're going to have a question where you have to simplify for trig, one of your trig identities, solve a trig question, and evaluate. So we'll practice one of each of those. So here on our test review, we only had verifying questions, but it'll be similar, but it won't tell you what it equals. So it'll just say secant squared times 1 minus sine squared, and you have to simplify it to see what it equals. So here we want to use one of our identities. We can find what 1 minus sine squared equals with our identities. So our identity that involves sine squared is sine squared plus cosine squared equals 1. To make this 1 minus sine squared, I got to move the sine squared to the other side. So cosine squared equals 1 minus sine squared. So I'm going to replace the 1 minus sine squared with cosine squared. So we have secant squared times cosine squared. We're going to find what this equals. We don't know what it equals. We're still simplifying. What else could I do here to simplify? I can change secant squared to be 1 over cosine squared. So 1 over cosine squared times cosine squared. Cosines cancel, so we're just left with 1. So the question on the midterm will say simplify. It'll be a simplifying question. So when it's verifying, it'll have the answer on there. So how could that be multiple choice? So it'll just be a simplifying, it'll be multiple choice, so take whatever it simplifies to. Kind of similar, good practice would be the quiz, the 5.1 quiz that we did. Practice a simplifying multiple choice. Let's do a solving one. We could do number 6. So to solve, we want to isolate our trig function, so get it all by itself. So here I'm going to combine my like terms. I'm going to add 2 sine to move it to the other side. And I'm going to subtract the 2. Let's move the 2 over as well. So we got 4 sine equals negative 2. To get the sine all by itself, we're going to divide by 4. So sine equals negative 1/2. Sine tells us we look at what on the unit circle? The y. I want to see where on my unit circle do I have a y value of negative 1/2. I'm going to paste my unit circle here. So negative 1/2 as our y value would be here at 7 pi over 6 and 11 pi over 6. So x equals 7 pi over 6 and 11 pi over 6. So looking at 22, we're going to use our sum and difference formulas here. So for 22, our question goes cosine, cosine, minus. So we want to see which sum and difference formula goes cosine, cosine, minus. So cosine, cosine, minus would be the third one. So it's cosine of u plus v. So the first number is going to be our u, the second one's our v. So cosine of 50 plus 10 would be cosine of 60. So we're looking for the cosine of 60. We're going to look at our unit circle. So we're going to go to 60 degrees. Cosine tells us we look at the x value, so that would be 1/2. This is what you're going to be given. So everything from the last test, you'll have the unit circle, the identities, so you'll have your reciprocal ones, and your sum and difference formulas. For practice, calculating your score, you can put it into a graphing calculator to see like what score you need on the midterm to end the class with whatever you want. If you want to click the y equals button, you can do 0.4 times your quarter 1 grade plus 0.4 times your quarter 2 grade, and then plus 0.2 times y. Nope, times x, sorry. We already have y. And then you click the, I think it's the trace button to actually see the graph. Or it might just be the graph button. We can do it together on the calculator if you want, but if you want to put your score into a graphing calculator, that way you can see on the graph, your x value is going to be what value you can get on the midterm. It'll kind of give you a range of x values to see what your overall grade is, which would be the y value. So if you want like a 90 or above, you can see what value, what grade you need on the midterm.